This template describes how to perform multiple replications in Stroboscope. This template can serve as a starting point for developing a full-blown model that performs multiple replications. The Stroboscope model would appear at the top of the set of statements that we see here. The statements that perform multiple replications appear in the last section, which has the label Initialization of Queues, running the simulation and presenting the results. It is always a good idea to have a display statement that provides information about the Stroboscope model itself. Such a display statement is shown here that provides the student name, the problem title, the case number, the date, etc. A key definition for this template is the definition of a variable called WEND replications, whose value determines the desired number of replications to perform on the model. The SaveValue run is initialized with the value 1. It will control the number of replications performed, and it will also serve as the run counter that will be printed in each row of the output. Notice that the name of the SaveValue run is succeeded by a star, and because of that, the SaveValue is made persistent. This means that the contents of the SaveValue run will not be cleared as a result of the clear statement that follows below. It is useful to define variables at this point that produce desirable results. For example, variable 1, expression 1. It is also useful to define persistent collectors to save data across replications. For example, here we define collector 1, whose name is followed by a star and which cannot be reset by the clear statement that is included within the while loop below. The objective of performing multiple replications is to produce a table of desirable results. The headings for that table are printed next. The example here shows a print statement that prints to standard output a format specifier enclosed in quotes. Notice that the format specifier actually occupies several lines of text in this file. The carriage returns that end each line are also part of the format specifier and will produce new lines in the output. Here we define the headings for 4 columns. The first column has the heading Run, the second one Result 1, the third one Result 2, and the fourth one Result 3. The word tab in square brackets indicates that at that point, instead of typing tab, the user should press the tab key on the keyboard to line up the output in columns. The format specifier ends with \n, which stands for the new line character. It produces a new line in the output, just like a carriage return or the enter key on the keyboard. Up next comes the while loop that will actually perform multiple replications. The while statement is followed by a logical expression. While that logical expression is true, the statements between the while statement and the when statement will be performed repeatedly. If the logical expression of the while statement becomes false, then the statements between the while statement and the when statement will be passed over and will not be executed. That is how a while loop ends. In this case, this while loop will be performed as long as the SaveValue run has a value which is less than or equal to n replications. The first statement inside the while loop is the statement clear. This statement clears the simulation system of all resources and non-persistent statistics. In this particular case, it would clear all the save values and all the collectors whose name does not end in a star. That is why it is very important that the save value run ends in a star so that its contents are not cleared by this clear statement. Then come the statements that control the performance of a simulation of the model. This begins with the statements that initialize queues. After the queues are initialized, then we have the statement simulate until, whose logical expression controls how long the simulation will run. In this particular example, the simulation will run until sim time exceeds a particular time limit. This will perform one replication of the model. After that replication is performed, comes a print statement that produces one row in the table of results. This particular example print statement takes as an action target the standard output, followed by a format specifier enclosed in double quotes, followed by 4 arguments, which are run, expression 1, expression 2, and expression 3. The format specifier in double quotes includes the format specifier %7(f), which prints run using 7 digits and 0 decimal points. After that, we have %15.9(f), which prints expression 1 using 15 digits, of which 9 are decimals. The format specifiers for expression 2 and expression 3 are similar to expression 1. Finally, the format specifier includes \n to start a new row for the results to be printed next. After a row is printed in the table of results, then we collect results so that we can have statistics to print at the end of the table. For example, the next statement collects into collector 1 the result of expression 1. Notice that expression 1 is the same as that printed by the previous statement in the second column. There should be several collect statements here, one for each result. After that comes the action assign, which takes as an argument the save value run and the expression run plus 1. The purpose of this assign statement is to increment the run counter by 1. The next statement, WEND, ends the while loop. When Stroboscope reaches the WEND statement, it goes back to the while statement and reevaluates its logical expression. If the logical expression is true, then the statements inside the while loop are performed again. If the logical expression is false, then the statements inside the while loop are passed over. This means that the while loop will be performed while run has the value 1, 2, 3, all the way to the number of replications, which in this particular example is 10. Each replication will print one line in the table of results and will also collect into the collectors one more data point for the desired results. After the while loop ends, it is time to print overall statistics for the various columns of the table using the persistent collectors defined above. Again, in the print statement below, we should substitute tab in square brackets with an actual tab character on the keyboard so that we line up the output in columns. The print statement that follows prints a row of equal signs to separate the rows of the various replications from the lines that follow, which will provide statistics for each of these columns. Then come 4 other print statements, each of which will print the average, the standard deviation, the minimum, and the maximum of the values collected by the collectors of results. Then we have a display statement that could provide some more results of interest from the last run. Finally, if we want, we could also have a report from the very last run. The above stroboscope statements produce the following tabular output for 100 replications. They are very similar to stroboscope statements produced automatically and behind the scenes by EasyStrobe to provide a table of results in Stroboscope when performing multiple replications. The first line identifies the user, the problem, and the date. After that comes the table of results. It begins with the headings of the columns, run, result 1, result 2, and result 3. A line of equal signs to separate the headings from the rows of the multiple replications that follow. A line of equal signs to separate the multiple replication results from the statistics below. And a separate line for the average, standard deviation, minimum, and maximum of the results. This template can serve as a starting point for developing a model that performs multiple replications.